All right. Thank you for joining us, the very second reading group meetup for the Dynamic Abstraction group. I'm super excited to have Sangho as a speaker today and discuss something very important, ladders of abstraction, which we all deeply care about. So Sangho is a postdoc in University of Toronto now. He's one of the founding members. He played a very critical role in shaping this community and leading the community engagements and workshops. Thank you very much to Sangho for all all this work. And Sangho has been very passionate in this space. He's one of the leading experts. He started work with his with CodeToon, which explored, comics to understand programming and learning, and more lately his work with AI interfaces like Luminate and other works have explored how to do sense making and explore design space with AI. So I'm really excited to learn about his take on ladders of abstraction in this age of AI. This is a 40 minutes talk with 20 minutes of Q&A and open discussions. So there is a Discord channel, which I will post in this message for you to post questions and make comments, and we will get into the discussion mode after the talk. And as a reminder, you can also suggest topics and speakers. You can also nominate yourself if you want to give a talk in our monthly reading group. So please go to our website and reading group page to suggest topics and speakers. With that, I will pass it to Sangho.
Okay, great. Thank you, Rubayat. Let me share my screen. And I see that there's now an option to also share myself like overlaid on top of the slide. Do you guys see that as well?
Yeah, I love it.
Yeah.
Or is it distracting? Or let me know if you guys prefer that I'm out of the way.
It looks good. Yeah.
I mean, the
Okay.
only problem is you might hide some content, but yeah.
Yeah.
Like, for example, we
mean,
cannot read the bottom of the slide.
yeah. Oh, let me just do the normal, typical one. I don't want to be hiding it. Okay. Hmm. Um, oh, okay. You guys can see the slides, right?
Yes.
Okay, great. Thank you, Ruat, for the introduction. And yeah, it's really great to be presenting on this topic, which I care deeply about. So I'm looking forward to just kind of sharing, what I've learned so far about the ladder of abstraction, and I'm looking forward to also hearing what other people's like thoughts are on how we can kind of apply this in various domains, and also what kind of implications it might have in the age of AI. Okay. All right, so today I would like to just kind of begin by introducing myself. Um, and I'll just talk about my first exposure to the level of abstraction, and what got me really excited about it, and how it kind of really shaped my thinking and research. And then I will oops. And then I will go into talking about the ladder of abstraction. I will spend the majority of my time on this topic, talking about what it is, kind of talking about its origin and the history around surrounding it, people who were behind this term, and also just kind of go into more concrete kind of examples so that you guys can think about, and we can all by the end of this presentation, my goal is that you guys have some understanding and clarity of why the ladder of abstraction is important, and when and where we can apply it, and what kind of design challenges might lie. And so yeah, let's talk about that. And then after that, I will open up the floor for open questions and discussion, like last time. And as Rubaya said, please feel free to use Discord, and then post questions there. All right, so just something about me. I first learned about the ladder of abstraction while taking courses in computer science as an undergrad student. And I did learn programming in high school, but I never considered myself as, someone that, thinks like a computer scientist. I never thought that I was like, born to be a computer scientist. But, over time, as I, took courses and learned, I could feel that, I was starting to think differently than before. And, I didn't know what it was like, back then initially, but over the course of the time, I realized that, it is actually the ability to shift between multiple levels of abstraction that really change the way I see things and see the world around me. And as Donald Knuth kind of describes here, I think our ability of being able to move between different levels of abstraction is something that you learn when you learn something like a computer science or engineering. And you know, and when I say like I learned it in courses, I'm talking about concepts like the OSI model or computer languages that are often explained using levels of abstraction. And I think the reason why, I became really interested in this is because I didn't just stop there, but I started thinking about how this approach, like kind of identifying and particular semantics and seeing the world and organizing information around those semantic levels, um, I could apply that in other things. So for example, I think what the level of abstraction allows us to do is think about the broader picture, right? We abstract and create a new semantic level, but also we have the flexibility to dive deeper into the detail and the low-level details. And I think it really what it does is it expands our ways of thinking and allows us to think and see things more holistically. And just to be more concrete, let's say you're thinking about AI's impact on labor economy, and there's an article talking about its impact on the society. So on one hand, you could say, okay, this is article is presenting this information about its impact on the societal level. But if you're kind of applying these, levels of abstraction, you might be able to kind of think about, oh, how would this impact also translate into people at an individual level, or more broadly at a country level, or more broadly across between countries, right? So I think this kind of is an example where I realized that, oh, this kind of enables me, gives me the ability to think more systematically and holistically, and even when I converse with people and exchange ideas, I realized that this really enables me to be more systematic and critical in how I assess ideas and conversations. And so this really kind of motivated me. And although it was quite abstract, and I couldn't find anyone kind of working on this ladder of abstraction, I had this vague thought that, okay, I want to build systems that enable people to benefit from this way of thinking. And this led me to eventually, for my PhD thesis, I was fortunate to be able to apply this abstraction ladder as a kind of a model for teaching computer programming. So, for example, what I did was, let's say the programming concept is conditional, and there is this kind of code example, right? And you could consider there might be another corresponding more concrete semantic level, like story, right? Uh, which kind of maps from the code. And then you might be able to also have this kind of visual language level, the comic level, that's the most concrete form of abstraction for this concept. So this is kind of what I worked on, and I'll talk about it a little bit more later down when I talk about the ladder of abstraction in more detail. But this is really kind of, it has such an impact that, I ended up actually pursuing PhD just really to understand how we can apply and use the abstraction ladder. And yeah, like as I said, I think even after my PhD, I ended up working on some of the projects that really required thinking about how we can incorporate this with the help of some of the co-authors who are here today. And I'll talk about some of them in more detail as well. So now let's talk about the ladder of abstraction. So what is it? I know there are some people who are already familiar, but let's just kind of walk through maybe the origin. Maybe you might not be familiar with that. So we'll talk about the origin and the key idea before going into some of the examples. So if you Google the ladder of abstraction, this is what you get. And in this explanation, it says, the ladder of abstraction is a concept created by S.I. Hayakawa that who proposed that language can be categorized as different rungs on the ladder, with the bottom rung being concrete language and the top being the abstract language. And so S.I. Hayakawa actually coined this term when he wrote the book Language in Action that you can see, which was published in 1939. And he was an English professor. So his kind of research was on language. So that's why he kind of approached the ladder of abstraction from the language kind of perspective, right? And he provided these two examples in his book, which I'll talk about. So the first one is kind of about this cow example. I don't know why he picked cow as an example, but so let's say we have a cow named Bessie, right? It's a very unique cow, right? But if you abstract away the details, like, and by details, what I mean is like, characteristics that really uniquely characterize this particular cow named Bessie, Bessie the cow, right? Its weight, its height, it's going to be different from any other cows, right? But if you abstract away some of the details that uniquely identify Bessie the cow, then you would have just a normal cow, right? And then as you abstract further away, cow becomes, you can abstract it to livestock. And then if you abstract it further, you would get farm assets. If you take away the farm kind of property, then you get asset and eventually wealth. So this is kind of one kind of abstraction ladder example that Hayakawa explains in his book. And the other one is about kind of how the ladder of abstraction, as you go up the ladder, you kind of generalize. So it's kind of in the form of a statement, right? So let's say, there's a lady named Mrs. Levin who lives in Chicago, and she makes great potato pancakes. And then if you abstract up, you might just say that, oh, Mrs. Levin is a great cook, right? Even though the only kind of dish you had was just a potato pancake. So there's no guarantee that she's actually good at other dishes, but you can abstract it, generalize, and say that she's a good cook. So you kind of extrapolate, right? And then if you extrapolate even further, even if Mrs. Levin is the only person from Chicago that you might go around and telling your friends that, oh, I think Chicago women in Chicago, they're all great cooks, right? So you're kind of really extrapolating again as you abstract. And if you even say, just based on your interaction with Mrs. Levin, eventually that the culinary art has reached high standard in America, then you have obviously extrapolated even much further. So this was kind of an interesting also example that he gives, and he goes on to say for the key idea that whether you're a writer or speaker or just a thinker, um, if you want to be this kind of interesting writer, informative speaker, or accurate thinker, you must be able to operate on all levels of the abstraction ladder, moving from higher to lower and from lower to higher. So this kind of principle, surprisingly, you'll be able to see throughout the slides as I go through, but just kind of highlighting this, and he kind of reinforced this even further by um, explaining the danger of remaining at certain levels of the abstraction ladder, and this is kind of a phenomenon also that this linguist called named Wendell Johnson. Who was here in the picture, he coined it, he described it as dead level abstracting, as in like, not abstracting, right? And he kind of provided this one example where he's kind of describing a speaker who might be talking just about very detailed instances or cases without abstracting to talk about the takeaway, for example, right? He's saying that, oh, the low-level speaker will frustrate you because you wouldn't know what the takeaway is because he's just bombarding you with information. And obviously, that's knowing this, I'm gonna try to stay away from that. Or you could also have a high level speaker who's just talking about these principles, the very abstract ideas, without giving you any examples, and that can be frustrating as well because you wouldn't know what it is that the person is talking about, right? So because of this danger, is Wendell is kind of saying, and Hayakawa is also arguing that the key to effective communication is, moving up and down the abstraction ladder. So that's the key idea I want you to remember as we go through. So as I said, since Hayakawa was an English professor, right, he was approaching this, he was seeing this from a language perspective. But ladder of abstraction, as you would know, obviously now, it's not just limited to language, right? The levels of abstraction, which kind of characterize like engineering field or computer science, it has been there, right? They just didn't use the term, the letter of abstraction, and you actually, I think the agreement is that Hayakawa is the one that first coined the term, but in any case, the whole concept has existed before, and it's just really a metaphor for levels of abstraction, which can be found in any other kind of fields as well, right? So the point I want to also make is that ladder of abstraction is not limited to language. It can be found in the system, as you saw, right, from the OSI model, and there's also a great article that if you you might have read from Brett Victor, who has written about up and down the ladder of abstraction, and I encourage you to go read it. And today, in addition to the system, I'm also going to talk about the ladder of abstraction, where each rung might be different representations, as you kind of saw briefly when I was talking about myself, my work. So having described the origin and the kind of the context around it, I want to go into some of the use cases and examples, and hopefully, we'll touch on some of these questions, like why it is important, when do you use it, where can it be applied, and what are some potential design challenges to them. So these are just four kind of domains I have these examples for, but during the open discussion time, if there are other examples, I'd love to hear. So as you could tell, the ladder abstraction, I think one of the great kind of domains that it can be useful for is obviously communication, right? And although Dijkstra wasn't necessarily talking about communication here, but more about programming, I think the whole idea, the message can still apply, where he's saying that the purpose of abstraction is not to make it vague, but to be absolutely precise, right? To find the right semantic level where one can be precise. And so I want to just kind of go back to this example that we looked at, where, right, let's say we have this, someone is saying, oh, Chicago women are good cooks, right? And but in reality, the person who's saying that might not, the only person that he interacted with might be Mrs. Levin, right? So oftentimes I think we make a lot of these generalizations, right? And I do that too, and we all do that. But I think if we are able to have some understanding of this kind of lot of abstraction and how we might be operating at the wrong level of abstraction, I think it can also address a lot of the challenges that I think actually happen because we operate and think at different levels of abstraction, where I think even if we're actually in agreement at a higher level, we might be talking about very low level details, and that we think that we disagree with each other, but actually at the higher level we agree. But that's for another discussion, and that's just one thought I had. And obviously, I think lateral abstraction is great for education. Really, so one kind of context that Saqib, I don't know if Saqib is here today, but Saqib is another member, founding member, and his work kind of explored how he can apply the lateral abstraction to improving how we teach math, right? And so what you see here is, right, the abstraction ladder and various representations that get used in math, right? So we have shapes, drawings, picture-based math, symbols, plots, visualizations, and complex expressions, right? And I think, we can kind of categorize them as, the first two as maybe concrete representations, which are grounded in actual objects, right? The things that we can touch and feel and smell. And the reality is that they actually convey the intuition better. And in abstract representations, maybe it's not as grounded, so it can be a little bit overwhelming for novices or people who are not comfortable with abstract expressions, but it's actually very powerful, right? So if we want people to be able to think in a powerful way, they need to learn to abstract and work with abstractions in general. But obviously, in learning, you need to be able to kind of adapt to each person's knowledge level and so on. And so I think, sometimes I think there's in education, there's an argument for starting with concrete representations, starting with intuition, and then gradually moving to abstract representations. So having said that, how nice would it be if we have a system where if I'm just learning for the first time, or if I have some gaps in my knowledge, I can go back to this more accessible representation and learn intuition behind it, and then go on to more complex ideas and expressions when I'm ready, right? So this is what Saqib kind of explored. As you can see here, there was and also Rubaiyat as well, as you can see. And he had this abstraction letter, which I loved seeing, where you can go from this symbolic expression level to iconic pictorial level representation. But he's also I'm gonna have Saqib explain, because we have a video here.
Represent a design framework that leverages visual description. Each representation is explorable in 3 progressive layers of mathematical abstraction. Hierarchical structures are explorable in the same way. The highest layer of abstraction gives us the symbolic expression h1 plus h2.
So you see, user is able to use the abstraction ladder slider to change the representation, right? So that's an example that I wanted to show. And yeah, I also did a very similar work, but in the context of teaching programming and also using different representation like comics. So as you can see, the abstraction ladder that I had in my system consisted of these 3 semantic levels: code, story, and then comic. And let me just kind of show you briefly how the system works. Oops, actually. Yeah, but basically, I don't have I think I forgot to include the interface, but if you're interested, you can take a look. But basically, it's very simple. You can kind of get the idea where you can input or add any code, like Python code, and then it would use a parser to parse it, and then create abstract syntax tree, like the intermediate representation, and you would use that for user to be able to add, like in the place of like x, like variables, you would add something like some more concrete objects like banana, and then you would be able to add kind of a narrative context, right? And then the system would automatically generate comics based on the story and then the code structure. And then obviously the ladder abstraction can we use it to design interface and interaction? Yes. And this is a work also I've done where if you look at the hierarchy view, like right now, the screenshot, you that was kind of inspired by the whole, the ladder of abstraction and kind of these key idea that we talked about, which is moving between different levels of abstraction and just enabling users to quick seamlessly move between the levels and dive deeper into the details when needed, right? So this video will just kind of show that where there are layers, and each layer might represent like a particular topic, like AI's impact on future work, or in this case, what is it? Yeah, the remote work advancements, right? So this was work, kind of reflecting, demonstrating how we can apply the ladder of abstraction to the interface design and the interaction experience. And also, as many of you might be already familiar with, the semantic zoom, right? So if the text is overwhelming, as you kind of zoom out further, you can kind of gradually change the level of detail, right? So and I guess it has existed without necessarily referencing the abstraction ladder, but you can imagine what kind of things we can abstract away, right? Now that we have AI, and this kind of touches on what does what kind of implications or lessons can we take away from the abstraction ladder in the age of AI? What you just saw was possible because AI can summarize it really quickly, right? And this is just another also example of semantic zoom. But what I want to maybe highlight here is that we had to, as a designers, had to decide which semantic levels make sense and are reasonable to have, right? So we have the title. So these are like the stories that gets generated. And basically the levels that we have are title, keywords, summary, and full text, right? So we have like 4 or 5 levels, including this dot level, which doesn't show any text. What's a reasonable number of semantic levels, right? Or which ones are relevant? I think, I don't think there's a particular answer. We can talk about that, but I think that's one of the questions we as designers had to kind of face and decide which are reasonable. And this is also another work from a colleague.
Programmers communicate with visualizations at many levels of abstraction, often through handmade diagrams and animations. We find that these visualizations aggregate operations, abbreviate repetitive steps, and provide an overview of the execution. Based on these patterns, we designed Crosscode, a visualizer for JavaScript that takes advantage of the program syntax tree, control flow, and data flow to visualize it at multiple levels of abstraction.
Yeah, what I really like is the way they kind of hide away some of the details so that and that's part of the design choice that they made. And I think the author, the lead author, Dev, is here. So if anyone has questions about the design choice, or we can probably talk about that during the discussion time. Co-letter is another work I did in collaboration with Ryan, I think, who's also here too. So I'll just play the video.
Collatter, a system designed to help programmers hierarchically translate their intent to generate code at multi-level abstractions. Collatter features 2 main UI components. The prompt tree editor on the left enables programmers to externalize their mental model. The code editor on the right allows programmers to verify their generated code and directly edit the program. Collatter is designed with 4 primary goals. First, Collatters assist programmers to transform linear prompts into structured trees. Programmers can decompose tasks into subtasks, utilizing a hierarchical structure to externalize their mental problem-solving model. Collatter will then generate code based on the prompt tree and align the code vertically with the task structure. Programmers can drag and...
Yeah, I'll stop there because I think this is probably the most relevant one, where the system that Ryan developed, if you kind of put a natural language prompt, which is like a high level goal that the user has, right? We often have to decompose if it's like a complex task, right? So AI is kind of assisting that. So I think, the ladder of abstraction obviously comes into play here, where I think it is it's not a very, it is not it is a non-trivial kind of task to decompose task, right? And I think that's why we tend to generalize a lot. Like the example that I had about Chicago women are good cooks, right? I think it's easy for us to kind of very generalized and kind of stay in the clouds. And I think maybe AI can help with that, right? Decompose and make sure we are grounded and precise in what we mean. And this is also another video that I'll just play, and we can first.
Green. And most of that detail isn't relevant for the task we're trying to do anyway. So you could wonder, can we use AI to bring these kinds of principles to other types of interfaces? For example, what would happen if I zoomed out on a book? What would that even look like? Typically, when we read a book, we're looking at every single word, but that's not the only level we think about. When remembering books we've read in the past or summarizing a book for a friend, we're more concerned with overall topics and plots than specific wording. And now that we have access to language models, which are amazing at summarizing and transforming text, how can we use them to change the way we read and write? So here's a quick demo I put together of the first 5 chapters of Peter Pan. And there's no tricks here. I'm just scrolling through the first chapter. So if we take this and we use an LLM to zoom out, we can see each paragraph change to a 1-sentence summary. And we have a mini map to the right, and you can kind of see how much fewer words there are in the page and how much more quickly I could read this. If we zoom out another level, we can see summaries of, say, 10 paragraphs at once. And again, you can see on the mini map, we have way less text to read. And then finally, at that highest zoom level, we've reduced each chapter in 1 sentence. Maybe has like 50 on the page, that'd be out just a little. But what it enable us to do, I thought it'd be really fun to share one of those with y'all today. All right, so completely hypothetical situation. Let's say I was going to an awesome conference in San Francisco. What I would do first is I would go to Airbnb, I'd find listings near the venue, I'd click into the detail page of one of the listings, and there's all this generic information that should work for everybody, but I have specific criteria that'll help me decide whether or not it's the right thing to book. So I'm gonna be digging through this page looking for things like how close is it to the venue, is there a coffee maker, does it have good Wi-Fi, that kind of thing. This kind of decision would be much easier if I could zoom out just a little. Get rid of all the branding and standard information that isn't really important to me right now and focus on my deciding factors. So to start, I can see the name of the listing, maybe the rating, a quick summary, and the total price. And this is all pretty generic so far, but I know this conference is at the esteemed Hotel Nico, and I'm typically going to be looking at a map to find places near that venue, but if I could just extract the walking minutes to the hotel and put that right on the page, that'd be really helpful. And maybe if that's a little bit far, I can figure out what is the closest BART station to the listing and then add the walk to BART there as well as a backup way to get to the hotel. Another thing that's really important to me is the Wi-Fi speed. I know I'm going to be working on my talk the night before, true story, so I'm gonna need really fast internet. So I can use AI to pull out the relevant reviews and summarize them as positive or negative to really quickly judge whether the Wi-Fi is gonna work or not. Additionally, usually Airbnb, most importantly, at this higher zoom level, preserving the ability to act on this information. So directly from this page, I can go ahead and reserve this listing or send a message to the host without going back to Airbnb. That would be really helpful and keep me in control. And I never really know whether staying at an Airbnb or a hotel is going to be a better deal, so typically I'll also look at hotel listings, and it's pretty great to be able to see that same elevated view no matter which site I'm looking at. Additionally, if I'm going to compare the hotel with the Airbnb listing, having these similar views side by side is going to give me a really easy comparison between the two of them. But what if I wanted to look at 50 listings? Comparing 50 of these individual views would still be a lot of work. Zooming out a level, I can look at a spreadsheet for all 50 listings with my deciding factors all laid out for easy comparison. So I can quickly eyeball the distribution for total price, get a sense of how quick the walks are for each of the listings, how many positive Wi-Fi reviews there are. Importantly, I can still take action on this level. So if I see a listing that's a clear winner, I can go ahead and book it right here, instead of going back to Airbnb or hotels.com. But sometimes the decision isn't so clear-cut, or it's more multifaceted than having the cheapest or the closest listing. So if I zoom out another level, each listing has been abstracted into a circle on a scatter plot, and these are colored by the Wi-Fi reviews. You can see the cheapest listings on the left of this plot with the most expensive ones on the right, and the closest ones to the hotel near the bottom. And I can pretty quickly see that there's this cluster of listings that are the cheapest and the closest, and they also have good Wi-Fi. But I just realized my flight gets in at 9 a.m. But thankfully, I can still initiate actions from this view. So I can circle these, send a message to all the listings within this cluster, ask them about their policy on early check-ins, and whichever one responds first that I can check in at 11 a.m., I'm going to go ahead and book. All right, so as we saw, there's so many tasks that are best suited by a specific Zoom level. And what we're currently doing is we're manually abstracting that information in our heads. So in this example, digging through 50 different Airbnb or hotel listings, we're keeping all of the previous ones in our heads to try to find the best one. And this takes a lot of mental energy. I know.
So that's a pretty cool idea. But Brian Min, a PhD student at UCSD working with Haijun, has actually worked on this very topic. So I actually asked Brian if he's willing to come in and talk about his project. So Brian, if you wanna chime in and then
Oh yeah.
take it away.
Hi. Yeah, hi,
Thank-
hi Ian. Wait. Yeah, it is related. So yeah, actually to answer your question, to kind of kill two birds with one stone, we've been thinking about this idea for I guess several years now already. And we also saw Amelia's video, and so I think we kind of converge into kind of the same kind of similar vision. But I guess this paper really kind of dives into how do we actually get that kind of demo that she showed, into our interfaces. And I think the main kind of investigation that we did was, well, first, this kind of interface that we're interacting with is called the overview detail design pattern. And so just by recognizing that this is kind of this ubiquitous design pattern, kind of allowed us to do this like huge analysis on over 300 interfaces. And by looking at all these variations, we kind of were able to figure out what are all these kinds of customizations that we want. And so this is kind of what our paper does. And I'm not going to go into all the details of exactly kind of what we did with that paper, but I'll just kind of stick with the framing of like the ladder of abstraction. I think kind of the main kind of principle that drove this paper for me was, rather than being able to climb up and down ladders of abstraction, for instance, like the overview and the detail view, I think that we should be rather being able to define those abstractions on our own. So I just call them user-defined abstractions, but really kind of this idea of pulling details from the detail view to the overview is sort of like kind of what drove my exploration. So I guess we can kind of see some of these demos I implemented for the paper. So I guess I'll start with the left side. They're playing at once, but on the left side I have this map view, and basically it's this idea of pulling information where I have certain details that I want, for example, the rating or the ranking of these different hotels. So instead of having to navigate and click every single pin on the map, what I can do is I can select some details, some attributes, and pull them out to the map view. And so then I can kind of just zoom out and see the overview with all the details that I want. And that's sort of like that concept of user-defined abstractions, where I'm defining exactly what kinds of attributes that I want to see in this abstracted view, which is the overview. And this is the same kind of concept that I'm applying with that phone demo on the right side. So this is sort of like a DoorDash mockup. And so what I'm doing is, instead of like having to tap through, looking through every single ingredients by opening the detail view, what I can do is I can kind of hold down on the ingredients kind of text and then tap surface. So let me see if I can play that again. I'm scrolling up, I tap on one sandwich, I hold down on the ingredients, and I tap surface. And so then that detail will surface and pull all the way to the overview for showing every single ingredient and calories for every single sandwich. And so that was one point of being able to define our own abstractions by pulling information. Kind of the second example is sort of using AI to do something similar with what Amelia did with seeing different scatter plots and different representations. Same thing here where we generate a different attribute of our own. So we're defining our own abstractions through AI by defining the color value of the couch. And then using that color value, what I can do is instead of since I pulled it out, I can actually change it. And instead of showing a list, I can show a color space that'll organize all the sofas. And so while AI is generating the color value for each sofa, it's going to place that sofa to where that sofa should be in this space. So those are kind of the two kind of directions that I was exploring with how we can define our own abstractions. For the second point, I think one question would be, it's great to have all these different representations like scatter plots, lists, maps, and all that. But how do we actually practically get all of those into a single interface? If you think about it, I'm not going to expect IKEA to develop like a color space or a map or like 10,000 other overviews or 10,000 other representations into their website. So I think that's something I'm thinking about. Just wanted to share that with the group.
Great. Thank you, Brian. Yeah, I'm sure we can talk more. But that's a great question. But yeah, I'm almost done, so I'll finish up and we can go into the discussion time. So just kind of revisiting this slide where I was talking about how the ladder abstraction can be found, in language and system design, representations. And I think I would like to share this quote by Hayakawa, who said that, all we know are abstractions. And, given that, our group is Dynamic Abstractions Reading Group, I would like to just highlight that, language, system, concepts, representations, they're all abstractions, right? And I guess when I think about the latter abstraction and when we kind of discussed the idea of having this dynamic abstractions group, I was thinking that the lateral abstraction could be one kind of a framework for to help us imagine how we might design these dynamic abstractions or dynamic interfaces representations. So yeah, just really nice to see that a lot of people now kind of are interested in this topic, and yeah, really excited to just kind of exchange ideas and continue to grow. So that was my presentation, and I did prepare some questions. But of course, you don't have to. If you have your own questions, obviously, you can chime in. But these are just some questions to get started. So the first question is about have you encountered build something resembling a lateral abstraction? If you benefited from using the abstraction letter, what was it, and what domains do you think need better letters of abstraction? What kind of challenges do you see when designing, which is kind of what Brian kind of talked about as well, and how we might design for serendipitous movement across levels, right? If it's not intentionally done, how can AI maybe they can infer that the user is stuck at a wrong level of abstraction and maybe guide them, right? Another question is how could AI support the creation or navigation of abstraction letters? And can we have a personalized letter of abstraction for individuals, right? Or roles? And how do we evaluate whether a particular letter that are designed is effective? And is the latter metaphor always useful, or would it be better to have another kind of a metaphor to kind of expand our a set of designs, that possibilities that we can think of? And should we, yeah. And that's it. And I did see Rubaiyat. I will let you kind of take it away. And I do see Damien raised hand, I believe, right?
All right.
I cannot see that.
Yeah, thank you so much, Sangho. So I will get back to Damien in a second here, but Sangho, I really like how you applied the principle of ladder of abstraction in your own talk. like giving up a history and overview and showing very concrete examples in communication, user interfaces, and search and so on. So thank you very much, Sangho, for this talk. With that, Damien.
Yeah, I was gonna say like great talk. Thank you so much, Sangho and Brian. It was super interesting. So my question is not related to the ones you're showing here. It's more of a
Mhm.
clarification question.
Mhm.
So I'm wondering if in your opinion, there's a difference between summarizing and abstracting. Because in many of the examples you see, you showed like, some of them you were talking about like, the women in Chicago, and like, you were
Right.
abstracting. So you were like, my understanding is like there was extrapolation. Whereas
Mhm.
to me, the definition of summarizing is there's no extrapolation. It's the exact same information, just shorter. And in some of the examples, it was summarization. Some others, there was extrapolation. So I wonder if there's a difference, if both of them, in your opinion, are like part of that ladder of
Mhm.
abstraction.
Yeah, no, that's a great point. I agree. I do think there's a difference, and I think let's say, right, like um I think, oh, one example I would maybe say is, so here, let's say I just take away, like I'm starting with the Mrs. Levin makes good potato pancakes statement. Let's say I just remove potato, right? Um, maybe that's um, mm, wait. So when you were saying, I would call that maybe just a summarization and not like extrapolating. Like if I just take away potato, right? So extrapolating, maybe the way we should define it is like if the distance that you go from the original content, original information, like if the leap is pretty significant, then it ends up becoming extrapolation. Does that kind of make sense?
Yeah. I was just wondering if like, both of them were
Mm.
part, because semantic zooming, typically, that's more
Hmm.
about summarization.
Hmm.
And there's not so much extrapolation in that context.
I
But
don't
like
know.
in your example that you're showing here, it's the
Mm,
opposite. Like there's extrapolation, but
right.
no summarization. Because like in fact, like when I go up the ladder, the text become longer.
Hmm.
And in some of your examples, it was summarization, some it was abstraction.
Right,
It's
right,
it's
right.
more of a like I was wondering if like
Mm,
you actually think about that when you design or just okay. But
mm.
I'm gonna stop there. Thank you.
Yeah, that's good.
I don't think semantic
Makes
zooming
sense.
necessitates summarization. I think you can implement
Mm.
semantic zooming, like it's an interaction technique, but it doesn't have to necessarily summarize the text. It can represent the text in different ways as you zoom out. So in that case, I guess I see summarization as more of like a form of abstraction.
Mhm, mhm.
Cool. Thank you. Next, Jasmine.
Yeah, let me build on that idea of extrapolation. I've been using boundary objects for this for workplace workplace ethnography. That's we have different disciplinary experts who I would say they share the same ladder. They're using exactly the same tool to zoom in and zoom out, but the extrapolations we're seeing are divergent. So this actually goes directly to your provocation. Should we be thinking about networks? And while that's instead of ladders, and as tempting a
Mm,
metaphor as that is, my experience with this kind of knowledge transit has really been it's much rarer. Where you really need the designer's attention is to find that shared ladder, the zoom that makes sense to two different parties at the core of it. And that's
mm,
such a powerful like orientation for design studies to take, for interface designers to build on. And I'm so excited to think more about how we bring other communities in especially when we're talking about these kinds of AI-enabled interfaces where we look at that and go say, oh, that's really good. Now to evaluate it with some people, just going to throw it at their heads and see what happens. Thank you for reviewing the literature in this space and pushing forward.
Yeah. Thank you, Jasmine.
Thank you, Jasmine. Matt.
Yeah, I think the as evocative as the ladder is, and I think that makes it a good tool for communication. I do feel like it's not a particularly complete model, because like in this example, for example, there's a lot of choices you can make, right? So you could make abstractions at the level of the cook, or you can make abstractions on what kind of food that is being made. And I think you could get to a point where like you can't really compare whether saying like, Mrs. Levin makes good food compared to or is a good cook, or Chicago may make good pancakes. Like those aren't really comparable with each other, but obviously they're comparable with the abstraction they've met before. You can also see this in professions, I think, building on what Jasmine was saying. One work I like a lot is professional vision, which is this idea that when professionals build expertise in a certain domain, they're able to see their domain in a specific way. And that domain, in the way that they see it, is an abstraction of the domain, obviously. Right. So the typical example is that, like, if you have two people looking at a patch of dirt, and one of them is a farmer and the other is an archaeologist, they both have abstractions about the kinds of things they care about dirt. And so they'll say a lot of different things about dirt, but those will be very different from each other. And some of them might overlap, right? So some of it, might be about like how dry the dirt is, but there's also different things, right? So like archaeologists care a lot more about the color of the dirt for various reasons. It seems like the commitments, I think the ladder of abstraction forces a lot of interactions to end up being this sort of linear thing, when I think there's a lot more flexibility than that. And so there's sort of the benefit of like saying like, okay, we're going to fix to one specific linearization, yes. But we could have picked another one. So like in the demo with looking at different Airbnbs with different Wi-Fi, there's like a lot of different ways you could represent that information, right? There's a lot of different choices you could make there. And so just saying like, yes, at the top zoom level, it'll just pick the right one, I think is limiting the sort of expression you could have in a user interface. So yeah, my question is like, how do you manage that, right? Because the space of ways that you can choose to abstract something is large for a given thing. And so when you combine that, stack it on top of each other, you kind of get a combinatorial explosion. And so it seems like we need a good abstraction for that sort of thing.
Yeah, thank you, Matt. That's a great point. I know there. Ruben, I'll let you.
Yeah,
I cannot see the Zoom, so.
So yeah, I think we will just take one more question, and there's also a lot of great references in the discussion in the related discussion channels. So we should just continue the discussion, but for the sake of time, we'll take one last question from Jeff, and then wrap it up. Jeffrey, I think I saw your hand raised.
Whoops, sorry, my Zoom froze for just a moment there. So I want to build on the thing that Matt just said, which is like, so when I look at, especially when I look at that hotels example, I agree that like I think this linear ladder, this conception of a linear ladder is maybe not quite the right thing, or it's probably situation dependent, but I think my concern when I look at that example is that it imagines a very purpose-built interface that's tailored to a specific task, and it's hard to imagine that we could ever cover all of the possible tasks that somebody might want to do. And I think this relates to thoughts about how like I've seen it said before that like interfaces are like inherently less composable than say programming in a textual programming language, and so yeah, I find it challenging to think about it. Is the visualization view where I get the hotels laid out on like a plot, is that a higher level, or is that just a different way of viewing that particular information that's tailored to my task?
Does someone wants to take, or
I mean,
oh yeah, go ahead.
well, I guess I think one way you could see it is that if you do if like the useful part about the ladder abstraction is maybe more as a metric, right? In the mathematical sense that you have like some kind of thing that is complex, but we can summarize it in terms of this ladder, which is not representing necessarily all the moves you can make, but it's representing a sort of a notion of a different level. And I don't know if that addresses the issue, but it's sort of a way to reconcile some of it.
All right. Thank you, everyone. Thanks so much, Sangho, for this amazing talk and leading the discussion. And thanks, everyone, for participating in the conversations. Lots of related work and interesting point of view in the Discord channel as well. So we'll wrap it up, but let's continue our discussion into the Discord channel. And Sangho, if you could just post the questions, the last slide you had in the slide. Discord channel, I think that will be a food for thought for think about and discussion.
Thank you, Rebecca, for hosting.
Thank you so much. We will post the recording.
Thank you, everyone,
and keep everyone posted. Thank you so much. Take care.
Thank you, everyone.